Hi, Algebra 2. I know we are finishing up. You guys just took your Unit 3 test, and it's holiday break is right around the corner. So I just wanted to introduce what we're doing next. Okay, nothing too intense, just so that a little preview of the next chapter, which is the quadratic. Okay, so let's just look at anytime you're given a graph that is new and you're not sure what the graph might look like, you can always just plot points, okay? We're familiar with y equals the absolute value of x, right? We've been doing that. It's a v, okay? If you think back, if we plot points, the absolute value of 0 is 0, the absolute value of 1 is 1, the absolute value of 2 is 2, the absolute value of 3 is 3. And then we have the absolute value of -1, which is also 1. The absolute value of -2 is 2, and that's how we get our v. Okay, so I want you to compare something that you already know, something we've been doing, with this new equation. The new equation is y equals x squared. Okay, so if you think about it, when I square a number, it also stays positive, just like the absolute value takes a number and keeps it positive, right? Similar with x squared, yet the graph looks a little different. Let's plot some points. Okay, when x is 0, 0 squared is 0. When x is 1, 1 squared is 1. When x is -1, -1 squared is also 1. So far, it's looking the same, isn't it? We have 3 points that are exactly the same on there. But let's go to 2 and -2 and see what happens. When x is 2, I don't just get 2. 2 squared, 2 times 2 is 4. -2 squared, -2 times -2 is 4. Okay, so we end up curving a little bit here, okay? We don't just go straight, like our v was, okay? We can try maybe plot 3 and -3 as well. 3 squared is 9, 3 times 3. -3 squared is 9. 6, 7, 8, 9. And -3 is at the same spot. So we end up getting something we call, a parabola. Hopefully you can graph it a little bit better. See how it curves? This is called a parabola. If you look up things that are parabolic in shape, parabola shape, something like the disc that, if you don't have Comcast or you get the satellite dish or whatever to get your TV, you'll see those sometimes. They have a parabolic shape. Okay, this is what we're studying next. And guys, listen, I'm going to be graphing on here by hand, and you can see that's kind of sloppy-ish. Remember, I don't mind you at all using Desmos. Maybe I should have graphed it here. Y equals, you know how to do this. We did it in class. There's y equals absolute value of x. Here's y equals x. Guys, to get the square, you have to use the caret above the 6. Above the number 6, there's this little caret. If I hit shift and that, notice how it puts an exponent there, and I can hit squared. And there we go. So it's similar to, see how on my graph, maybe you couldn't see this, the shape of it's already starting here. The only things that y equals absolute value of x and y equals x squared have in common are the 0, 0, the -1, 1, and the 1, 1. They're not the same, like right till 1 and then take off. See how this curve with the fractions, okay? See how that works? You can always graph on Desmos. If it gets annoying graphing on paper, Desmos is a great tool. You can see the differences, okay? Remember how with the absolute value, we talked about a slope? I would use that word and always put my quotes because it's not really a slope, but kind of, okay? I notice if I go up 1 and over 1, I'm back on the graph of an absolute value, right? Up 1 over 1, okay? Notice every 2 is actually 1, right? Every 2 little spots. So when I go up 1 and over 1, I'm back on the graph. Up 1 over 1, back on the graph. Up 1 over 1, back on the graph. Same to the left, up 1 over 1 back on the graph, up 1 over 1. So that's how we knew, the number in front. Anyway, with the parabola, it's a little different. Sure, I go up 1 over 1 on the back on the graph, but certainly up 1 over 1 again, I'm not. Up 1 over, it's curving. So you go up 1 over 1, but then you have to go up 4 and over 2. See that? Because what point is on the graph? 2, 4, right? 2, 4 is on the graph. So you don't just go, you go up 1 over 1, that might work. But you also want to go up 4 over 2, and then that'll show you that you have a parabola the same width as the parabola of y equals x squared. We'll talk about that a little bit more. Okay, everybody all right? That's our new unit. It's called the quadratic. Okay, the quadratic equation is anything that has an x squared in it as the biggest exponent. Okay, if your biggest exponent is x squared, you're looking at a quadratic equation. Let's look at these two now. Let's remember, what did, when I added 3 to the absolute value of x, do you remember how that changed it? Didn't it move it up 3? And then we still had our same v happening up here, right? Remember? Okay, we just took our test on this. So hopefully you're remembering that. Let's see what happens with y equals x squared plus 3. Okay, this time if I put 0 in, 0 squared is 0, plus 3 is 3. If I put 1 in, 1 squared is 1, plus 3 is 4. Negative 1 squared is also 1, plus 3 is 4. 2 squared is 4, plus 3 is 7. Negative 2 squared is 4, plus 3 is 7. So I'm going to graph 0, 3, 1, 4, negative 1, 4, 2, 1, 2, 3, 4, 5, 6, 7, and negative 2, also 7. So I see, yeah, the same kind of thing happened with my parabola, right? It's just shifted up 3. Has the same width, up 1 over 1 from the vertex. If I go up 1, 2, 3, 4 over 2, yes, I know I didn't graph it very well, but okay, up 2, 3, 4 over 2, I'm back on the graph. It's the same width as y equals x squared was. It's just shifted up 2. Shifted up 3. All right, everybody okay? Remember what subtracting 3 did? Think about it. Just pause me for a second. Go to Desmos and graph these two yourself before I do it, okay? Okay, so hopefully you graphed it. Okay, let me show you here. This is what we have, right? When we subtract 3, hopefully this is what you got. Instead of at 0, 0, I'm down 3. That's what x squared minus 3 looks like. See the blue graph? Okay, and it's the same width. If I go up 1 and over 1, I'm back on the graph. If I go up 1, 2, 3, 4, and over 2, I'm back on the graph. Okay, so that's what happens when you subtract 3. Same things that happen with the absolute value is what I'm trying to show you. Okay, all right. So comparing those, what happened when we added 3 on the inside of the absolute value? Remember how this caused us some trouble because it ended up kind of being the opposite of what we thought it was going to be, right? The absolute value of x plus 3 ended up shifting me 3 to the left, right? Correct, right? So x plus 3 on the inside. Think about what that looks like. You can pause me if you want. Okay, I'm going to go to Desmos and remind you that if we have an x plus 3, look what it did. Shifted that 3 to the left. Well, the same thing's going to happen here if I have in parentheses x plus 3 and then I square that. Okay. It moved my parabola. The vertex is now not at 0, 0. It's at negative 3, 0. Okay, it shifts it to the left because look what happens. If I put negative 3 in for x, negative 3 plus 3 is 0. 0 squared is 0. Okay, it doesn't shift me 3 to the right, because if I put 3 in here, I get 3 plus 3 is 6. 6 squared is 36. The point 336 is on there. I can't even see it on my graph. I can scooch it down here if you want to see it. 336. There we go. It's there. It's on there, 336. Okay, but I couldn't see it if I want to see the vertex, etc. There we go. Okay, that's what adding 3 does. Let's try the next one. Comparing. Okay, what's minus 3 going to do? Huh? Isn't that going to shift me to the... Who's going to say it? Good, to the right. All right, and if you want to, go ahead to Desmos. I love graphing on Desmos. And instead of a plus 3, I just have to change that to minus and see what happens. Oh, shifted it to the right. There goes the minus here, shifted it to the right. Okay, so the same things. We're not doing anything too new, except now instead of a V, we have a parabola that we're shifting around. Okay, right? Let's try this one. What happens if I multiply 3 or a third times the x squared? I'm taking away the absolute value now, okay? I think you have the idea that whatever we did to the absolute value, the same type of things are going to happen to the parabola, okay, as far as how we shift. Think about what happens if I multiply by 3 or a third. Go ahead and pause me and see what happens there. Okay, when I multiply by 3, I do my squaring first, then multiply by 3. So the 0 is still 0, but 1 squared is 1 times 3 is 3. Negative 1 squared is 1 times 3 is 3. 2 squared is 4. 4 times 3 is 12. Negative 2 squared is also 4. 4 times 3 is 12. So I have my 0, 0, but this time instead of 1, 1, I'm up 1, 3. Negative 1, 3. 2 takes me the whole way up to 12. That's 10. Well, I'm going to go up here. Negative 2 takes me to 12. We get this skinnier, more narrow parabola than we had when we had y equals x squared. Isn't that what this number did to our v? Made it more narrow? A third, let's see what happens with a third. 0 is still 0. 3 squared is 9. A third of 9 is 3. Negative 3 squared is 9. A third of 9 is 3. 6 squared is 36. A third of 6 is 12. Negative 6 squared is 36. A third of that is 12. So 0 gives me 0. It takes me over to 3 till I get 3. And negative 3, 3. 6 gives me 12. And negative 6 gives me 12. So I get this wider parabola, right? The 1/3 made my parabola wider. That was the same thing we had before, guys. Okay, so let's try all these. Go ahead and pause me. Let's see what we get here. Okay, so notice that the x squared is the red one. That's the normal one. 2x squared made it skinnier, just like 3x squared made it skinnier. Negative 2x squared just took that one and flipped it upside down. Do you see it? It's flipped upside down. That's what the negative on the outside does. Okay? All right. So what I want you to do is think about where this would shift. Okay? I'm going to shift it 4 to the right and 5 down. Isn't that what happens? I shift the parabola 4 to the right and 5 down. It's going to be down here, and it's also going to be skinnier. Okay? It's going to be shifted 4 over positive 4 down 5, and it's going to be skinnier than this because of the 2. All right? Try it on Desmos if you don't believe me. All right, so let's figure out the last part here. Okay, the A, I'm going to pause myself and write these notes, okay? Okay, so in 25 seconds, A, remember, either makes it go upside down if it's negative. If the absolute value of A is less than 1, like a half or 2/3, it makes it wider. And then, wait a minute. and more narrow if the absolute value of A is greater than